telescoping series. Objectives. By the end of this lesson, you should be able to recognize a telescoping series and find the sum of a telescoping series. Alright, the best way to tell you what a telescoping series is to show you what it does. So let's try to determine if the series, the sum from n equals 1 to infinity, of 1 over n minus 1 over n plus 1 converges or diverges. So right now we should be thinking we don't really have a lot of tools to figure this out. And if we try to break it up and take the sum of each one separately, all we have so far is the nth term test, which would tell us nothing, that this is inconclusive. So let's write out a few terms in the series. So the series of n equals 1 to infinity of 1 over n minus 1 over n plus 1. So first we substitute in 1. So 1 over 1 minus 1 over 1 plus 1. So that would be 2. So that's the first term. Plus, now we're going to substitute in 2. So 1 over 2 minus 1 over 2 plus 1. So 3. Plus, now we're going to substitute in 3. 1 over 3 minus 1 over 3 plus 1 would give me 4. And let's go one more out, plus, when I substitute in 4 now, I will get 1 over 4 minus 1 over 5, plus dot dot dot, etc. So now, let's try to see what's happening. Since everything's being added or subtracted, technically all these parentheses don't need to be here. And if they weren't here, maybe we would be able to clearly see what would happen. That negative 1/2 or minus 1/2 plus 1/2 would cancel and give me 0. And negative 1/3 and plus 1/3, or minus 1/3 and plus 1/3 would give me 0. And minus 1/4 plus 1/4 would give me 0. And we can see that the next term in the sequence would probably be, or would be, 1/5 minus 1/6. So you guessed it, the minus 1/5 and the 1/6 would cancel and give me 0. And this is going to happen for each subsequent pair of terms in the series that we add together. So the only thing left is 1. So this series equals 1. Now, why is this series called telescoping? Because if anyone has ever used or seen a telescope collapses on top of itself. So maybe especially if you've seen those toy ones that can stretch in and out that you can see through, they collapse in on themselves. So that's what a telescoping series does. The sum of the terms in the series nicely cancel out in this pattern and only leave 1, 2, or a few terms left over that we can add together, and that's the sum of the finite series because everything else will cancel out. And there's only one unique way that this is going to happen. So that's why the only thing left is going to be 1. So informally, a telescoping series is one where past a certain point the terms cancel out and collapse on each other and leave the infinite series to sum to just a few terms at the beginning of the series. So let's do one more example of this. Determine if the series, the sum from n equals 1 to infinity of 4 over radical n minus 4 over radical n plus 2 converges or diverges. So what's the indicator that you have a telescoping series? You probably have a difference of two rational functions, or two function over function type of problems. So here I have the sum of n equals 1 to infinity of 4 over radical n minus 4 over radical n plus 2. So we have 4 over the square root of 1 minus 4 over the square root of 1 plus 2, so 4 over radical 3. That's the first term. Plus 4 over, well now I'm going to plug in 2, so 4 over radical 2 minus 4 over the square root of, if I plug in 2, I'm going to get, what, 2 plus 2 is 4? So minus 4 over radical 4. And resist the urge to simplify because you're trying to see eventually what is going to end up canceling out. So plus 4 over the square root of 3 minus 4 over the square root of 3 plus 2, so 5, plus 4 over the square root of 4 minus 4 over the square root of 6. Alright, so let's see if we can see a pattern of what's going to cancel out now. So we can see that the minus 4 over radical of 3 plus 4 over radical 3 will cancel. Minus 4 over radical 4 and plus radical 4 over 4. And then let's write out one more term here. This would be 4 over rad 5 minus 4 over rad 7. So the minus 4 rad 5 and the plus 4 rad 5 would cancel. So it looks like what we're going to have left is 4 over the square root of 1, which is just 4, plus 4 over the square root of 2, because nothing else is going to cancel out with this 4 over the square root of 2. But everything after this point is going to cancel. So this is the sum of the telescoping series.